Exercise 1.1, question number 3. So use division algorithm to show that the square of any positive integer is of the form 3p or 3p plus 1, where q is some integer. So here what I am going to do is I am going to prove the square of any positive integer is of the form of 3p or 3p plus 1 format. So now what I am going to do is let a be any positive integer and my b value as 3. So what I'm going to do is a is equal to bq plus r. That is our division algorithm, where 0 less than or equal to r less than b. So what I'm going to do, a is equal to bq, that is 3q plus r, and 0 less than or equal to r less than 3. So now what would be the possible r values? R is equal to either 0 or 1 or 2, because r is less than 3. Now if I implement r value as 0 from the above equation, r is equal to, if r is equal to 0, a is equal to 3q. So when I do square of this number, a square is equal to 3q square. That can be written as 9q square. So 9q square can also be written as 3 into 3q square. So 3q square, what I'm going to do is I'm going to assume this value as p, and it can be written in the form of 3p, where p is any integer, positive integer, where my p is equal to 3q square. I'm assuming that this value is 3q square is equal to p, and it is an integer, which is a positive integer. Again, if I do the same thing for r is equal to 1 from the above equation, that is a is equal to 3q plus r, a is equal to 3q plus 1. So when I do square of this, how it will be written? 3q plus 1 whole square. It is in the form of a plus b whole square. So what is a plus b whole square formula, which we already know? A square plus 2ab plus b square. And if you write a 3q whole square, that is 9q square plus 2ab, 2 into 3q, 6q into 1, that is 6q plus 1 square, that is 1. It can be written in the form of 3 into 3q square plus 2q plus 1, and it can be written as in the form of 3p plus 1, and where I am assuming here p as 3q square plus 2q. And now if you see, it is in the form of 3p plus 1, the square here it is 3p. And similarly, if I take r is equal to 2, where a is equal to 3q plus 2, and a square is equal to 3q plus 2 whole square, that is equal to 9q square plus 2ab, 2 into 3, 6q, 6 into 2, 12q plus 2 square, that is 4. And if I wanted to write by multiple of 3, what I'm going to do is 9q square plus 12q. This 4 I'm splitting it as 3 plus 1. So now what I'm going to do is, if I divide it 3 into 3q square here, and 12 4 times plus 1 plus 1. So now what I'm going to do is, this part I'm going to assume as p, that is 3 plus 1. Here p is equal to 3q square plus 4q plus 1. P is any integer. And here in all these cases, you will be able to write the square of any number. This number square can be written in the form of either 3p, that is 3p, or 3p plus 1 format. So that's the reason. So you can write any of the positive integer in the form of the square of any integer in the form of 3p or 3p plus 1. So we have given the solution also. Just see at the end of this slide how to do it in the exam. See, let a be any positive integer and b is equal to 3, where you will be getting a is equal to 3q plus r, and 0 less than or equal to r less than 3, and the possible values are 0 1 2, and a is equal to 3q if r is equal to 0, a is equal to 3q plus 1 if r is equal to 1, a is equal to 3q plus 2 if r is equal to 2. So first one, a square is equal to 3q square, that can be written as 9q square, which we will write it as 3 into 3q square. That means when I assume as p, then automatically p is equal to 3q square, then a square is equal to 3p. P is any positive integer. Similarly, second one, a is equal to 3q plus 1 whole square means a square is equal to 3q plus 1 whole square. So here 9q square plus 6q plus 1, it is in the form of a plus b whole square. A plus b whole square is a square plus 2ab plus b square. And if you take 3 out from here, 3 into 3q square plus 2q plus 1. So here you assume it as p, 3q square plus 2q, and a square is equal to 3p plus 1. And finally, the last one, a is equal to 3q plus 2 whole square means 9q square plus 2ab, 2 into 3q into 2, that is 12q, plus 2 square, that is 4. Again, 9q square plus 12q plus this 4 can be written as 3 plus 1. So if I take common across all these 3, if you take that 3 out, 3 into 3q square plus 4q plus 1 plus 1. So this can be assumed as p, and p is any positive integer. A square is equal to 3p plus 1. So always either you will be able to write it as 3p or 3p plus 1. So that's what. Therefore, the square of any positive integer is of the form 3p or 3p plus 1. Okay.